So for lesson 3.1, that's this one, we're going to start with a parabola. That's my graph that's shaped like a U. Notice this is a non-example because this is a linear equation. For a parabola, we have either standard, we're going to start with two equations, standard form, which is ax squared plus bx plus c. And we're also going to do vertex form, which you've seen before. It's the one we use for transformations, where h is your axis of symmetry. And for standard form, my axis of symmetry is negative b over 2a. C is the y-intercept. Little things that you need to know for a parabola. Here we have the y-intercept definition. Y-intercept is where your graph crosses the x-axis. Non-example can be any other point that's not on the y-axis. Sorry, it's where the graph crosses the y-axis. For vertex, vertex is the h and k from vertex form. It's this point right here. It's either the highest or the lowest. This one doesn't have a vertex because it doesn't have a turning point. It doesn't turn around and go back the other way. So this one does not have a vertex. For my maximum and minimum value, if you have vertex form, you know the vertex. The vertex is very, very special. That y value on the vertex is your minimum or your maximum. So whatever that k value is, that's your maximum here, and that's your minimum here. These are non-examples because you're not my lowest or highest points. Axis of symmetry also uses a vertex, but now we use the h value because axis of symmetry cuts your graph in half, and to cut it in half right down the middle, you have to have a vertical line. Vertical is bucks, vertical undefined, and x equals. Non-example can be any line that doesn't cut your graph in half down the middle. Rocks, roots, zeros, x-intercepts. They all mean the same thing. They have 4 different names for them. Solutions. Solutions is wherever your graph crosses the x-axis. It's the same thing for the zeros, the roots, the x-intercepts. Notice we can have 3 different cases. One where my graph crosses the x-axis, so it has to come back up. So I have 2. One where my graph bounces on the x-axis, so I only touch it once. And one where my graph doesn't even come near my x-axis, so there's no roots. Those are actually called imaginary roots, which we're going to find using the quadratic formula later on. Non-examples is anything that's not on the x-axis, so any other point could be a non-example. So let's put it all together by doing a few questions. So for this question, I'm asking for the vertex first. Vertex is this point, so look at the x value, which is right here, it's -1. And the y value, which is right here, it's -3. Now that we have a vertex, we can kind of use that same number to figure out that maximum or minimum. Remember, the vertex has your maximum or minimum on that y value. It is definitely my k. So my maximum is -3 because it's that highest y value. Axis of symmetry is the h value, so -1. Axis of symmetry cuts my graph in half here. Notice it cuts the x-axis, that's why it's x equals. For my direction of opening, my graph opens down. Domain is always going to be all real numbers because you have an arrow on the left side and an arrow on the right side. Domain is from left to right, and they both have arrows. For range, however, notice I don't have an arrow going up because I have a maximum on top. So I go from bottom to top. On the bottom, I go down to -infinity. On the top, my maximum is -3. Now for increasing and decreasing, that's where I really use my my axis of symmetry, because that's where my graph stops going one direction and it starts going the other direction. So I'll start with increasing, and we're going to use the x values. So I start with increasing. On the left side, x is always negative infinity. On the right side, x is always positive infinity. So I start with negative infinity increasing until I reach this x at value. My x value here is -1. And then starting at that -1, my graph starts going down. So I'm going to decrease. And I decrease starting at that x value, which is -1. And I decrease forever, so until infinity, where x never ends. So I'm going to bring those over. I increase from negative infinity to -1 and decrease from -1 to infinity. We're going to do the same thing for the second question. My vertex is my h and k, where h is 1 and k is -4. That's definitely a minimum or a low value. Axis of symmetry, I use the h value. My direction of opening is up. Both arrows are going up. My domain is always going to be all real numbers because I have arrows on the left and right side. For my range, I have a minimum, so I have a bottom, but I don't have a maximum, so I don't have a top. Now for my increasing and decreasing, follow your graph. I start by going down. So I'm going to start with decreasing, and then I'm going to increase. Drop your infinities. Negative infinity on the left, positive infinity on the right side. And then I look at the number where I stopped increasing and I started to decrease. So I was decreasing until I reached this number right here, which happens to be my axis of symmetry, which is 1. And those are my intervals of decrease and increase. Okay, now for transformations. This is the same transformation paper that you used before. You should have a green paper like this in your notebook by now. A is your vertical stretch or shrink. When A is bigger than 1, we stretch, meaning we get skinnier because we're stretching up. When A is less than 1, which is the fraction, we're going to shrink. The fraction has to be less than 1. If I have a negative, that means I reflect it on the x-axis. A negative is not part of a stretch and shrink. It's separate. H, if you add a number on the inside, you go to the left side. If you subtract a number on the inside, you go to the right side, and that's because H is always the opposite of what you see. And K moves you up if you add or down if you subtract. Again, H and K is your vertex. So if you can find them, H on the inside, K on the outside. If you can find those two numbers, then you have your vertex. You have your starting point, which means you have your axis of symmetry, you have your domain, your range, all of that awesome stuff. It all comes from the vertex. So the trick is that your vertex, the H value is always flipped because it's always the opposite. So this will be +2, -3, -2, and -3. The K does not change because that's not the opposite. And if you don't see a number there, like this one, then it has to be 0. So let's try a few questions to see if we get it together. This first equation, my vertex comes from the H and the K. H should be with the x squared. K should be on the outside after it. There's no number here, so I'm going to assume that H is 0 and that K is 4. So that's my vertex right here. Now there's no negative sign, which means my graph opens up like that. This is definitely a low point, so I'm going to call it a minimum. And my axis of symmetry is x equals 0. Now, to transform, to get this equation, all I did was move my parabola from this middle point up. So I went up 4 units. That also comes from the K right here with the +4. That +4 tells me I moved up 4 units. This next example, I'm going to start with the transformations with this next one actually. Again, my H and K. H is +1 because it's the opposite. K is not there, so it has to be 0. So I know my vertex is 1, 0, but notice there's a negative sign right here. That negative tells me that I reflect on x-axis. That means my graph opens down. And then I have a -1 inside of the parentheses. That -1 moves my graph to the right 1 unit, which is why my vertex is here on the right side. Now the reflection means I open down like that. This is definitely a maximum value, and my y value is 0. Axis of symmetry is x equals 1. Now from here, all you have to do is describe the transformations. It helps to label them, like this is transformation number 1, number 2, number 3. This next one has 2 transformations, the negative and the 4. That 1/3 is a less than 1, so it's a vertical shrink. The +2 moves it to the left 2 units, and +1 moves it up 1 unit. I did all of that just by looking back at this right here. +2 is to the left, +1 is up, 1/3 is less than 1, so it's a vertical shrink. This next one has a negative, negative is a reflection, and then it has a 4. The 4 is greater than 1, so vertical stretch. So reflect on x. Vertical stretch. Now for this one, we're working backwards. It tells you that the equation has a vertical stretch, so a equals 2, and a reflection, so a equals -2, followed by a translation down, so k is -3. And now we write the equation using those numbers. So I have -2 x squared. There's no h because I didn't move it up. Nope, that's wrong. Oh yeah, there's no h because I didn't move it left or right. My k moved it down, so there's a -3 at the end. That means my vertex is 0, -3. The -3 because I moved it down, 0 because I didn't move it left or right.